This is the homework video for Wednesday, 2/8/17. You're working in your Unit 5 homework packet, page 19, number 2. Be sure to try it yourself before you watch the video. Be sure to listen for the secret messages. And remember that you can skip letter B. A says that Elena and Lynn are training for a triathlon, and Elena runs her mile at a constant speed of 7.5 miles per hour. But Lynn's times are recorded every minute. So the first thing I wanted to do is figure out how far in 1 minute. 1 minute Elena could do, because they're giving you miles per hour here. I know that in 1 minute Lynn can do 11 hundredths of a mile. So what I did is I put 7.5 miles over 60 minutes because there's 60 minutes in 1 hour. And then if we divide 60 by 60, we get 1 minute. And if we divide 7.5 by 60, we get 0.125, which means that Lynn is actually going a little tiny bit faster per minute than Lynn is, because she's going, if you round this, about 13 hundredths of a mile in 1 minute, while Lynn is going 11 hundredths. Sorry, Lynn, this is Lynn, this is Elena, so it was actually Elena. I'll change the answer there. So it was Elena who's going faster, because Lynn's going 11 hundredths of a mile in a minute, and Lynn is going about 13 hundredths. This is Elena, sorry. Elena is going about 13 hundredths of a mile in a minute, so that should be Elena. Make sure that you have the work for how I converted the 7.5 miles an hour into, I divided by 60 here, and I divided by 60 here, because there's 60 minutes an hour. I also just wanted to see, since I know that in 9 minutes Elena could do 1 mile, how far Elena would be, because this is Lynn. I keep forgetting that. This is Lynn. Elena would go 1 at about 13 hundredths, while Lynn is only at exactly 1 mile in 9 minutes. So the first secret message that I want you to write down is, sometimes relationships are linear, but they're not perfectly linear. Sometimes relationships are linear, but they're not perfectly linear. And Lynn's graph and table and graph are a really good example of that. So here she's going pretty consistent, but it's not perfectly consistent. So if you doubled 11 hundredths, you'd get 22 hundredths, and then be 33 and 44 and 55 and 66 and 77, and then 88, and then 99. Well, it's really close to that, and if you look at the way they plotted the points, you can see it's not a perfect straight line, but it's super close. And so it's really important to understand that sometimes things aren't 100% perfectly linear, but they're still called linear. And we'll talk about that more, I think, in the next unit, Unit 6. You didn't have to do B, so I just crossed that out. Moving on. The last question says, for these models, is distance a function of time, or is time a function of distance? And explain how you know. So distance is a function of time, because the more time passes, the further Elena and Lynn are. And second secret message, it wouldn't be possible for time to be a function of distance, because how could time move more quickly or more slowly based on how far you are? Time can't be affected. So that's the second secret message. And the homework video is done. Less than 5 minutes. Hope you have a great night. See you tomorrow.